Good afternoon, students. Good afternoon,
Good
students.
afternoon, sir.
Yeah, good afternoon. Thank you. So today we will see the last topic of our third unit, regression. So when you finish this unit, I expect you to have some basic knowledge about what is meant by regression, what are the types of regression, and what application we can make use of regression. So today we'll see some a different regression topic. And with this, the third unit will be completed. And for your second internals, you will have unit number 2 and unit number 3. Let me share my screen. Is my screen visible?
Yes, sir.
Okay. So today we are going to see logistic regression. So far what we have seen is linear regression in the sense that you have a straight line as a hypothesis, right? And this is normally used in the concept of decision trees. So the algorithm or the method which we saw in detail, how you need to grow the tree, how you need to cut the tree, what are the measures you need to take into account when you cut the tree or the grow the tree, all our entropy information gain, everything make use of the linear regression. Right? As I told you, linear regression is used for some applications where finally you need to detect or predict a number, right? What is the price of the house? What will be the temperature after 2 hours? What will be the electricity consumption rate in a specific street, something like that, right? So when you go for classification, it is all about saying whether this is cat or dog. But when you go for regression, it is all about finding the single number. But whenever your input changes, like our y is equal to mx plus c, whenever x changes, your y also will change. So now we are going to move into another important concept called as logistic regression. So I'm going to explain you this logistic regression with respect to our linear regression. So when you understand these two differences and the similarities, then you will realize how logistic regression is different from linear regression. So first linear regression, as we saw, is a commonly used supervised machine learning algorithm that predicts continuous values. Right? When we say continuous values, your x is not a single value. Your x is going to have a set of values. So whenever x changes, your y also will change. That's why we say regression talks about continuous values. Specifically, linear regression talks about continuous values. And it assumes that there is a linear relationship between dependent and independent variables. That's what we were saying in the past 5 or 6 classes. In simple words, it tries to find out the best fitting line, right, or a plane that describes 2 or more variables. This is what we have seen so far. Now we will go into logistic regression. Interestingly, the statement which I'm going to give you is contradictory to what I have told you earlier. Logistic regression is another supervised machine learning algorithm that helps fundamentally in binary classification. Right? I never told you that regression can be also used for classification because regression is different, classification is different. But in regression, we have done a modification, which I'm going to call it as logistic regression, which is actually used for classification applications. Right? So what is classification application? Saying whether it's a cat or a dog, whose input is not going to change. Whenever I show a cat, it will be categorized either as correctly as cat or sometimes it may be misplaced in the dog category. So those comes under the discrete values. Classification is always discrete. Regression is always continuous. But one specific difference is that logistic regression is normally used for classification. Right? Linear regression only for regression. So this is what we are going to see, how this logistic regression is used for classification. Although the usage of linear regression and logistic regression is completely different, right? Linear regression only for regression, logistic regression, even though it has a name regression, within it, it is used for classification. Mathematically, we can observe that with additional step, we can convert linear regression into logistic regression. That means logistic regression doesn't have any independent algorithm or method. It is actually based on linear regression. So once you understand the concept of linear regression, from the linear regression, if we make one or two steps, we will be able to classify it into either dog or cat, the input data into dog or cat, right? So that's why we have the word regression within logistic regression, because it is actually dependent on linear regression method. So now, when you want to learn logistic regression without learning linear regression, it is not possible, because first we are going to follow linear regression. At one point of time, we are going to take a slight deviation and say that we are going into classification mode, and that is called as logistic regression. We will start from the scratch. Most of the concepts we have already learned, but we will go by a step-by-step procedure. What is step one in linear regression? So let us assume that we have a data set where x is the independent variable and y is a function and y is the dependent variable. Y is the output, x is the input. This we have already seen. Just by using linear regression, we can form the following equation. Y is equal to mx plus c. M and c are constants which we want to find out, which we can find using stochastic gradient descent algorithm. And whenever x changes, y also will change. This is step number one. Step number two. Now I know the equation of line. Now I want to find the best fitted line. Right? I can draw line anywhere. You give me a paper, I will draw line anywhere. But which is the best line? So for that, I need to find out the constants m and c. Constants m and c. Right? Only if I fit properly this m and c, this equation will be a correct equation. How do you say correct equation? For all values of x, I will get a correct value of y. So we assign, initially we cannot find out m and c directly. So what we do? We assign random values to m and c and calculate the corresponding value of y. This y value is called as the output value, but that value may be wrong because the parameters I have chosen for m and c are only random. Step number three. So now we have got a random output, which I'm going to call it as y cap. Now I'm going to check whether my y cap is correct or not. If my y cap is correct, then the random selection of m and c is correct. But normally it doesn't take place, right? Y cap cannot be initially correct. So I'm going to check whether it is correct or not, or accurate or not. So in case of linear regression, we calculate the residual or error. Do you remember what is meant by error or residual? Y minus y cap. We try to find the difference between y and y cap. Y is the original output and y cap is your estimated output based on your random selection of m and c. If this residual is huge, then we say that y cap is not exactly equivalent to y, because y cap minus y will never be equal to 0. Right? So how do we find the error? By using the mean square method, which we saw extensively in the previous classes, and we name it as loss function. Right? A loss function can be written as error function. Error function is loss function. It's written as y minus y cap the whole square. Right? I have also told why we went for the square. You can also have y cap minus y. That is also fine, because anyway, negative or positive, when you get a square, you are going to have only a positive value. So this we already saw. So what is the next step? Now to have the best line, to best the hypothesis or the best line, we need to find the minimum value of error. What will be y cap in such a way that my error will be minimum? Or in other words, what should be the correct value of m and c so that y cap will be close to y, so that my error value or loss value will be minimum. So to minimize the loss function, we use a technique called as gradient descent. Our previous derivation where we went for chain rule of differentiation and we found an expression for B naught, new values of M and C and the old values of M and C. Step number 5. Once the loss function is minimized, once we minimize the loss function or error function, we get the final equation. How do we get the final equation? When the loss function has a minimum value, when the loss function has a minimum value, then it says y cap is very close to y. So when will be y cap very close to y? When you have a proper value of M and C. Right? So that we say is correct. Right? So when you go take this M and C and go to fit into the y is equal to mx plus c line, then we say that is the correct final equation. And we can predict the value of y for any given x. Right? Once you choose M and C correctly for any data of x, your y will be giving you the correct predicted output. Right? So these 5 points, whatever I have told now in 5 steps, this is what we saw in 5 classes, 45 minutes previous sessions, right? So this is all about linear regression. Now we are going to take a small diversion. This is all about prediction. So whenever you have x, you get a value of y. This is all about prediction. Now, how can I make this adaptive to be suitable for a classification process? So this is where linear regression ends, and we are just one step away from reaching to the logistic regression. So now we will go into logistic regression. How do I do that? So logistic regression is used to classify elements. It is not the concept of regression, even though it has a word regression within it, but it is used to classify elements of a set into 2 groups. So whenever I have maybe a domestic animal, a wild animal category, whenever I see a goat, I put into domestic, a cat, a rabbit, domestic, bear, tiger, lion, I may put into wild. Right? So my output is going to be discrete, this or this. But how am I going to do in logistic regression? By calculating the probability of each element of the set. What do you mean by each element of the set? This is nothing but x, my input data. Right? I have a larger x may have 10 values. That's why I'm replacing x with a different value and finding y. So that x is nothing but the elements. So inside that x, I will have many dog, cat, and many things will be there. So I'm going to find out the probability. In previous classification applications, I am going to clearly say that this is dog, this is cat. Right? But in logistic regression, this is the important point you have to note down. Even though it is going for classification, it is going to give you only probability. Right? That means 60% it can be wild animal. It is not 100%. That's why people rarely use logistic regression for classification when you have already other very good classification algorithms, which we are going to see in the subsequent classes. But nevertheless, this can be also used for classification. So how I'm going to determine the probability and how I'm going to say this is a dog or cat? Step number 1, right? So step number 1, where do you get step number 1? From step number 5. Already we have the y value for a specific x value. Now the predicted value, what do you mean by predicted value? The y. The y is the predicted value. Gets converted into probability value. Easily I'm going to convert into a probability value. So what do you mean by probability? Any value with a range between 0 to 1 can be called as a probability value. 60%. What do you mean 60%? 0.6. So how many different percentage you can have between 0 to 1? Infinite. Right? So my duty is now I have y as a whole number. I am going to convert it into a decimal number or a probability number. How? By feeding it to a sigmoidal function or a activation function. You can call it as a sigmoidal function. The equation for the sigmoidal function is again very simple. The input, what is the input for this sigmoidal function? It is actually the output from step number 5. So that y will be taken and it will be given here. The formula is 1 by 1 plus e power minus x, where x actually corresponds to y in our case. Right. So for all whole numbers or integer numbers of x or y, you are going to get s of x as a decimal value or a fraction number only. If you have calculator with you, you can just check with a random number. X, you take any whole number, e power minus x, and again you are going to take 1 by 1 plus e power minus x. So definitely you are going to get a number between 0 and 1. That is taken to be the probability value. Right? So that y for a specific x, you are getting a specific y. Now for that specific y, you are going to have a probability value. Okay? So the sigmoid function converts the predicted value into a value whose range is between 0 to 1. That is we call as probability. Now this is the graph. This is the graph which will look like for a logistic regression. This is the graph of a sigmoidal function. Right? Because of the shape, yes, this is also called as S curve. Linear regression is for a straight line, but logistic regression is like a S curve or a sigmoidal function, where you can see your x-axis is 0 to 6, even negative values you can have, that doesn't matter. But when you look at your y-axis, the maximum range is only 1. Your graph cannot go beyond 1. That means whatever number you give, it will be compressed or squeezed within the range of 0 and 1. That's why we choose this sigmoidal function to convert my y value, predicted value, into a probability value. Right? So as you know, if you have a x of 2, just extend that line in the vertical direction. Wherever the graph strikes, take the point, you will have 0.8 or something. Now with this probability value, right, the output value of the sigmoid function gets converted into 0 or 1, that we know. Now we are having a threshold value. Because logistic regression is used for binary classification. What do you mean by binary classification? Only two chances, either dog or cat. But we also have multi-level classification where you can classify into 3 categories or 4 categories. Right? But logistic regression is used for binary applications where we are going to set a threshold as 0.5. So whenever my value, my probability value falls less than 0.5, I say that let me put in one category. Or whenever my value exceeds 0.5, then let me say that I put in another category. In that way, my binary classification is achieved. So even though it is a logistic regression, by a simple step, maybe 1 or 2 steps after linear regression, we go for our classification. You take any input x, use linear regression to find y, take that y, give it to a sigmoidal function, it will be converted into a probability value, check whether it is less than 0.5 or more than 0.5. If it is less than 0.5, then that corresponding x, that input, right? We are not bothered about that y. The corresponding x is this category or the other category. In this way, we can get the binary classification. We'll see a small example. Let us consider a problem where we are given a data set containing height and weight for a group of people. Our task is to predict the weight for new entries. Right? Maybe you people, 75 students are in the class. Now I have, based on the height and weight, I'm forming a line. Okay, if this is the weight, maybe this is the height. So whenever a new person joins our class, if the weight of that person is given, I am going to find out the height. Or if the height is given, I'm going to find out the weight. So x and y. Given x, I can find y. So this application comes under the category of logistic regression. So we figure out that this is a regression problem where we build a linear regression model. We will train the model with provided height and weight values. Once the model is trained in the sense that SGD algorithm, all those steps, we can predict weight for a given unknown height value. Any new height value, we can predict the weight. Now, after predicting the weight, now the doctor or someone suddenly come and tell you, I need to do one more step. What is that one more step? We have an additional field called as obesity, and we have to classify whether a person is obese or not. Obese or not, depending upon the height and weight. Normally, you can find out that with the help of weight alone. But how do you get weight? You do not have the weight. From the height, you get the weight, and from the weight, you are going to say whether he is obese or not. So this application now comes under the category of logistic regression. So these 3 points as linear regression and also your logistic regression. So this is clearly a classification problem where we have to segregate the data set into two classes, obese and not obese. So for the new problem, we can again follow the same linear regression steps and build a regression line. This time the line will be based on two parameters, height and weight, and the regression line will fit between two discrete set of values. To get a better classification, we will feed the output values from the regression line into a sigmoidal function. Sigmoid, sigmoid, sigmoid. Why sigmoid? Because it is the only, not only function, because it is one of the functions which is going to give you a value between 0 and 1. That is what we need. We take it as a probability value, compare it with our threshold, a predefined threshold, and say based on it. The sigmoid function returns the probability for each output value from the regression line. Now, based on a predefined threshold value, we can easily classify the output into two classes, obese or not obese. Right? So this is the way how your logistic regression graph looks like. Right? So not obese. That means when your weight is low, we can say it is not obese. Right? But again, that weight is dependent on your height. This graph is almost framed from the linear regression model. So when you look at the highest point, the weight is more. When the weight is more, you say that it will be most probably obese. So I hope you would have understood the concept of logistic regression. The only thing, a highlighting point is logistic regression is used for binary classification. Right? Similarities, both are supervised machine learning algorithms. They need the target vectors. Both models are parametric regression. Parameters means variables, right? You have some variables. Logistic regression also depends upon linear regression. You have age, gender, and everything to predict something. So dependent variables and independent variables. So we call them as parametric methods. Now, these are two similarities, but we have plenty of differences between linear regression and logistic regression. Linear regression is used to handle regression problems only. Never ever forget this. Linear regression is used to handle regression problems only, whereas logistic regression is used to handle the classification problems, specifically the binary classification problem. Linear regression provides a continuous output. When we say continuous output, whenever X changes, my Y also will change. But logistic regression is more for classification. So it comes under the category of discrete, this or this. The purpose of linear regression is to find the best line. That means to find M and C. Right? While logistic regression is one step ahead and it is used for finding the lines to the sigmoidal curve. Right? Whenever you have a line, how the sigmoidal curve should change so that it can go for a better classification. The method for calculating loss function in linear regression is the mean square error, as we saw. Whenever error is minimum, that is the correct value of M and C. Whereas for logistic regression, it is probability. It is probability. There it is mean square error, but in logistic regression, it is probability. The technical word for probability is maximum likelihood estimation. What is the maximum probability? If it is 0.7, okay, let me put in category 1. If it is less than 0.7, let me put in category 2. So whichever probability is maximum, based on that, we are going to have a decision likelihood. So if you ask me a question, sir, for classification, can I make use of logistic regression? I will not advise you to go for that, because probability means it is not the exact value. 70% it may be wild or it may be domestic. But there are some other very good classification methods or algorithms like our decision trees, which we use for regression. There are some algorithms which work well. But if you want to practice or test this, then you can make use of a simple. So with this, we have covered third unit, 3 units, and I am sure that you would have got some idea on regression, which is very, very important. Now you should be in a position to say that whatever application you have come under the category of whether regression or classification. You must know the differences between a regression and classification. And we saw decision tree algorithm, which is widely preferred for regression. Normally, these mathematics people, the BSc maths, MSc maths, and people who are doing research in mathematics related stuffs, they normally go for regression, and the word which they commonly use is called as curve fitting. Right? Curve fitting is nothing but what should be the correct position of line. But when we go into exact machine learning and computer science related applications like prediction or classification, we normally go into classification applications. So now if you have chosen a mini project and if you are using a machine learning for it, you can easily identify whether it comes under the category of regression. If you have any doubts, you can ask me. Let me mark attendance in the meantime. When do you have your first exam? When your second internal starts?
March 10.
10th.
Yes, sir.
So maybe we can continue with our 10th in the sense today is 4th, right? 4th, 5th, 6th, 7th. So maybe we will have one or two classes, but that's fine. We will go into the next unit, but that will not be included in your internals. We'll have second and third. That's fine. Amulya, answer your attendance. Yeah. Okay. Judson.
Yes, sir. Present, sir.
Okay. Samyukta. Samyukta. Angel. Angel. Angel absent. I could not see Angel here. Is Angel here? Okay. Angel absent. Ajit Pawan.
Present, sir.
Abhinaya.
Yes, sir.
Kiran Kumar. Kiran Kumar. Okay. Manideep. Manideep absent. Banu Teja.
Yes, sir.
Jennifer.
Yes, sir.
Priyadarshini.
Yes, sir.
Jeevan.
Yes, sir.
Afreed.
Present, sir.
Jayant. Jayant. Jayant not there. Vikas.
Present, sir.
Paul Finney.
Present, sir.
Bhuvaneshwar. Bhuvaneshwar. Okay. Sumant Kumar.
Present, sir.
Ramesh Kumar.
Present, sir.
Dheeraj Kumar.
Yes, sir.
Zubair.
Yes, sir.
Kirti. Dinesh.
Present, sir.
Tejaswant.
Yes, sir.
Chandana Priya. Chandana Priya. No. Karthik.
Yes, sir.
Vijay Kumar.
Sir.
Soman.
Yes, sir.
Janish. Janish. Janish absent. Rex Vimal.
Yes, sir.
Harshavardhan.
Present, sir.
Uday. Sakib.
Present, sir.
Siddharth.
Yes, sir.
Siddharth. Okay. Praneeth.
Yes, sir.
Salome.
Yes, sir.
Libinson,
Yes, sir.
Alan,
Yes, sir.
Ronan, Ronan absent. Sai Kiran, Sai Kiran absent. Joshiba,
Yes, sir.
Shiny,
Sir, 56 present, sir.
Shiny. Okay. Jasmine,
Yes, sir.
Kavya,
Yes, sir.
Jaysurya,
Yes, sir.
Ronapal,
Yes, sir.
Manasa,
Yes, sir.
Ashrita,
Present, sir.
Narasimha Reddy,
Yes, sir.
Puneet Kumar,
Yes, sir.
Shiny,
Yes, sir.
Joshua, Nagakiran,
Yes, sir.
Suraj,
Yes, sir.
Maunika, Taufik,
Yes, sir.
Manideep,
Present, sir.
Dikshit,
Yes, sir.
Maria Angel,
Present, sir.
Amrut,
Yes, sir.
Pavan Kalyan, Pavan Kalyan, okay, Sainath, Gautam,
Yes, sir.
Jagat Chandra, Vivekananda,
Yes, sir.
Prashant,
Yes, sir.
Sai Ganesh,
Yes, sir.
Gopichand,
Present, sir.
Ritvik,
Yes, sir. Yes,
Solomon,
sir.
Solomon, Solomon Raj, absent. Sudarshan,
Yes, sir.
Sujit
Darshan,
Kumar,
present.
Present, sir.
Suresh Kumar, Suresh Kumar, absent. Sunny,
Present, sir.
Amrita Das.
Present, sir.
I'll read out the absentees. Number 3, URK number 3, 7, then 15.
You will
Number
7%.
Vinapa,
7%, sir.
where were you?
Sir, I was telling, sir.
15.
Sir, 15.
Number 3 absent. Number
15 has put it in chat box, sir.
okay. 36,
36 present, sir.
40.
Sir, 40%, sir.
Yeah, it seems like that I am taking once again all attendance. 54.
Yes, sir.
See, try to give the attendance in the first attempt itself. 133.
Yes, sir.
133 also present. 138.
Yes, sir.
So the only absent is Angel. URK 003. Okay, students, we will meet in the next class. If you have any doubts, you can ask me now.